Hey, welcome to my office. Just wanted to introduce this next video as a video talking about AC and DC coupling on off-grid solar power systems. So most of this will be me rambling on a couple of sites. So let's cut to it. Hey there, I wanted to show you a DC coupled system. So this is where the DC panels come straight through the charge controller, and behind me is a Easy Solar 5000. So that's an all-in-one unit where you've got the Easy Solar inverter, which is the top half of the unit, and you'll have an MPPT charge controller as well. At the moment you can hear the generator running behind us. We're just giving the batteries a good old boost up there with the generator. So the Easy Solar is, as you said, an all-in-one unit with a couple of breakers in it as well. So we've got the mains going out to the house, we've got the generator input breaker, and here we've had a caravan type generator inlet plug just mounted on the side of it, nice and easy. We have the main battery isolator in there, so not that you'd ever need to disconnect the main battery unless you need to reset the system. And Easy Solar also comes with this Color Control GX unit, so it's really is good value for money, the whole Easy Solar all-in-one. So the CCGX talks to the inverter, it talks to the PV charger, and it monitors the battery as well, and monitors the generator input through the inverter, of course. So what you get is you get an overview of how the whole system's running. But what you also get with the CCGX system is if you connect it through to the internet, you can use a Wi-Fi dongle for that, or you can use an Ethernet plugged straight into your router. So you connect it through to the internet onto your Wi-Fi router, and then what you can do is you can go on to the Victron Energy VRM portal, and you can get the data for the system basically coming through from here, so you can see remotely, and it records all the usage and solar production and battery condition over time. So now this is called a DC coupled system because you've got DC coming in from the panels, coming through the circuit breakers and into the bottom of the inverter, where you've got the charge controller tucked up there in the bottom of the Easy Solar unit. So that's basically coupling the batteries to the solar panels using a PV charge controller, and so that it stays in DC all the way. So from the solar panels into the charge controller, DC into the batteries, and then when the power is needed, back out into the inverter and out to your loads, which is your house basically. So it's DC coupled. And next we will have a look at an AC coupled system that instead of using the charge controller, we're using a grid tie Fronius inverter that the panels connect to the grid tie inverter, and they will connect, the grid tie inverter will connect onto the load side of this main inverter, and so the grid tie inverter will then backfeed through the main inverter into the batteries, and that's called AC coupled. So let's have a look at that one now. Okay, so this one is what we call an AC coupled system, and we've also got some DC on here as well, which I'll explain shortly as to why we do that. But you can see behind me there we've got a Multiplus 5000. That's just an inverter charger, so what that means is it inverts to 230 volts from the batteries, and when you plug a generator into it, you get the mains coming in, and it will turn into a charger and start charging as well. So now what we have here beside it is a Fronius inverter, which is a PV inverter designed for connection to the grid. So it's what we call a grid tied inverter. So the PV comes from the panels straight into the grid tied inverter, and then the power from the grid tied inverter goes straight into the switchboard in the home. Now that means that power is 230 volts, and it is available for any appliances to use in the home whenever there's solar being produced. And so it goes straight from the solar panels through the main grid tie inverter into the home. And then what happens is, if that energy is not being used, then the Victron inverter will take the excess energy and then pump that back down into the batteries and charge the batteries. So this is what we call AC coupling. So it's a grid-tied AC inverter using the AC line to couple the solar panels to the batteries. So when you're talking about coupling, you're talking about how the solar panels getting to the batteries. And in this case, we're going AC coupled from the solar panels into the Fronius. You can see there it's doing 456 watts. It's near the end of the day and it's overcast. Into the panels, and then into the battery inverter, the Victron, and then into the batteries from there. What we also have on here, if you notice, is down here we have a Victron charge controller. So now that is a DC charge controller, and that is taking DC from the part of the array and pushing it straight into the battery. So you can see you've got a PV input there, and then you've got a battery output. So what that means is we've got a little bit of DC going into the batteries directly as well. Now you may go, well, why are you doing that? Why would you have two devices, an AC inverter and a DC charge controller? So the reason you do an AC coupled system normally is because it's pretty quick and easy to install. So you've got one string of panels, or maybe two strings of panels, and maybe 10 or 12 panels on a string. So you've got a lot of panels, and a lot of installers know how to do that system really well, and they can get it installed really quickly. And you've just got one string, which means, let's say one string for now, it means you can just bring one lot of panels, one wire down to the inverter, and then you connect it to the inverter, and then you connect that inverter straight into the switchboard. Now, if you look at the earlier on in this video, you would have seen with a DC coupled system and a large array, you actually have to run your panels in strings of 3, or maybe strings of 2, but generally you run them in strings of 3. So 3 panels in a row, then back down. Another 3 panels in a row, back down to the charge controller. 3 panels in a row, another string back down, another wire back down from that string. So what happens is you get a lot more panels on the roof. You get a lot of cables coming down from the roof rather than just 1 or 2 cables coming down. You'll get 5 or 6 cables coming down, maybe more coming down from the roof. Those cables then go into the fuses, because when you get more than 2 strings together, you need to have fuses on all the strings. So what you find is when you get a lot of panels and you want to do DC charging, so you're charging from panels, DC coupled through a charge controller straight into the batteries. When you do it that way, you actually have a lot of work cut out for you in wiring all of those strings down from the roof, and then also wiring all those strings into the isolators or the fuses or breakers, whatever you've chosen to use, and then you wire them into the charge controller and onto the batteries. However, if you only wire 2 strings or 1 string in a DC coupled situation into the same charge controller, you can get away legally and safely without needing to fuse it. There's a whole lot of reasons for that, but I won't go into that. So that means you could run a small number of panels. So in this case what we've got is we've only got 6 panels running into this little charge controller here. But why have DC at all when we've got AC coupled solar. So the reason is that in the odd occasion when your batteries get really low, and that often happens at winter, so you're using your power still, you've got really bad weather, your batteries get low, you need to start the generator. Now what happens if the generator has run out of gas, or it won't start, or both, or either? You just can't start that generator. Then your batteries are going to continue to discharge in the bad weather. Eventually the inverter will cut off the AC power to the house, because it's not going to risk those batteries getting damaged. So we will program that at a certain point where it will cut off so the batteries don't go too low. So when that inverter cuts off the power to the house, it's also cutting off the power to the inverter that manages the panels. So the problem there is that inverter, because it's designed as a grid-tied inverter, it's not legally allowed to produce energy when it's got no power to it. And practically the way they build them is it can't produce energy anyway, not reliably anyway. When 230 volts onto the mains, when that 230 volts goes away from the mains coming in from the grid, or in this case the battery inverter, that inverter shuts down. It shuts down immediately. It will not restart until we've got 230 volts going back into the house. So there's not going to be 230 volts in the house, because this inverter here is saying the batteries are too flat. So this inverter will start up automatically when the batteries start lifting up a bit in their charge. So we put a few panels on, so that at least if we get a catastrophic failure and at night time the whole system turns off, at least the next day when the sun comes out, you can get a little bit of charge back into the batteries through that DC, 3 or 6 panels on the DC side directly charging the batteries. And then once the batteries are up, the inverter will click back on, and that will bring in the main AC inverter, and then suddenly all of your panels are charging at full noise. So that's why it's really important to have a good mix when you're doing a larger system and you have AC coupled, which is efficient and cost effective and really quick and easier to install. That's why you should have a little bit of DC on there as well, so that when the batteries go right flat, cut out on safety, so we don't damage the batteries, then you've got some DC there, so the next day you can bring those batteries up a little bit, click, the whole system comes in, and then the rest of the solar array comes in and then just boosts the batteries back up again. That's if you have a generator failure. So basically you can probably get away with running without DC for maybe 2 or 3 or 4 years, but there will come a time where you will have a cutout condition unless you've got a really good generator maintenance plan. You will have a cutout condition maybe in 4 or 5, maybe 6 or 10 years later, and you won't be able to recover from that cutout condition unless you have that generator running. So that means you've got to go down the road, hire another generator, beg from a neighbour, borrow to get the power back on. But in this situation, at least you've got some charging coming from the DC. Okay, so that's an AC coupled, DC coupled mixed system. Just beautiful.